Now we have to discuss the topic application of a UJT. Yesterday we have to saw the working construction of the UJT. So main application of UJT used as a relaxation oscillator. Yesterday we have to discuss. So what is the negative relaxation oscillators? The negative resistance of UJT. We discuss UJT exhibit negative resistance characteristic above the certain value of VE and emitter current IE begin to flow, increase until peak voltage VP IP are reached at peak point P. After peak point, in an attempt to increase VE is followed by sudden increase in emitter current with corresponding decrease in VE. This is the negative resistance portion of the curve because with increase in IE, VE decreases. In negative resistance region, with increase in IE, VE value decreases. At peak point P, current will begin to flow from the emitter into base region because the base region is very lightly doped. The addition current causes conductivity modulation, which reduces the addition current causes conductivity modulation, which reduces the resistance of the portion of the base between emitter and junction. Emitter junction and B1 terminal. This reduction in resistance means that emitter junction is more forward bias, so even more current is injected. So overall effect is negative resistance at the emitter terminal. So this is the relaxation or negative regions. Relaxation, this point used as a sawtooth generator. Second, overall over voltage detector. It can be used as a over voltage. Sometimes we have over voltage, which is sudden increase in voltage is called over voltage. Due to some changes in the line, the sudden voltage will increase. That can be controlled. It can be used as a sine wave generator. Pulse generator. It can be used as a pulse generator. We know what are the pulses. Different pulses we have already. So pulses sudden changes its value. Sharp change in value and have some constant value and suddenly decrease to lower value. It's called pulses. It is used in switching circuit, many switching application. In triggering circuit, switching means trigger circuit, phase control circuit, timing and triggering circuit. Timing circuit and triggering circuit. Phase control means controlling the angle of the any signal at the input, which is 90 degree or 80 degree or 180 degree telos. So it also used for triggering of thyristor, multivibrator, counters. Multivibrators we have already and counters. So it is used in counters. These are the different applications we have seen. Sweep circuit or voltage regulator supplier, it is also used in sweep circuit. Now we have to discuss the second topic is photodiode. So we have to discuss the construction detail of photodiode, characteristic of photodiode, and operation of photodiode. How it is constructed, what is the difference between normal diode and this photodiode, we have to discuss. Normal diode and the photodiode, we have to discuss the value. Next point is, so photodiode has many applications. Here actual normal diode, we have only normal constructions, we have normal doping, but photodiode has it made up photodiode is made of specially made diode, specially made, so it is called special semiconductor device. So it is look like a normal photodiode PN junction device which operate in reverse bias. So photodiode mostly operates in reverse bias. So it is differ from rectified diode in a sense that it's a reverse current increase. It's a reverse current increase with a light intensity at the PN. As light increase at a junction, it increases the current in reverse bias. But in ordinary diode cannot increase. It cannot increase. Only magnetic carrier will flow. When operated in reverse bias, photodiode work as a photoconductive cell, and with no bias it acts as a photovoltaic cell. When we apply some reverse bias, photodiode work as a photoconductive cell. With no bias it acts as a photovoltaic cell. So this is we have to see the construction figure of the photodiode. So the symbol is shown as in light is falling onto the junction, light. So it is the diode is encapsulated in plastic capsule, and we made a small hole at the junction lens, so that whenever we focus the light onto the lens, the light will flow from lens to junction. So whatever the energy which has in light, it can be absorbed by the junction. Photodiode is a light sensitive device. It is also called photodetector, which convert light signal into electrical signal. The cross section of diffused photodiode, it is seen that thin heavily doped p-type layer is situated at the top, where it is exposed to incident light. Junction depletion region penetrated deeply into the lightly doped n-type layer. This is in contact with lower heavily doped n-type layer, which connect to the metal film contact. A ring-shaped contact is provided p-type layer. It is basically reverse biased p-n junction embedded in clear plastic capsule with the whole side of plastic capsule except one painted black or enclosed in a metallic case with lens. Light is permitted to fall on the surface across the junction. Remaining side of the casing are painted to restrict penetration of light rays. A lens permits light to fall on the junction. Photodiode is made of semiconductor p-n junction. It is kept in sealed plastic or glass casing. The cover is so designed that light rays are allowed to fall on the surface across the junction. Remaining side is painted to restrict the penetration of light rays. As seen, lens has been used in the cap of unit to focus maximum light on the junction, reverse bias junction. The active diameter of this device is about 2.5 mm, but they are mounted in standard TO5 package with window to allow maximum incident light. So active diameter of this device is 2.5 mm, but they are mounted in standard TO5 package with a window to allow maximum incident light. Next we have to discuss operation. The basic arrangement of photodiode is as shown in the figure. We know rectifier diode has very small reverse current when it is reverse biased. Under dark condition with a reverse bias, diode current is extremely small, almost constant, independent of reverse bias magnitude in normal diode. This current is called reverse saturation current and flow due to thermally generated electron hole pair. When light fall on reverse bias PN photodiode junction, additional electron hole pair are generated. Such a radiation may be considered as a minority carrier injector. These injected minority charge carrier are swept across the junction to produce additional reverse current flow. These injected minority charge carrier are swept across junction to produce additional reverse current. Increasing the junction illumination increase the number of charge carrier generated. Increasing the light, it increases the number of charge carrier generated. Thus increase the level of reverse current. The magnitude of the current under large reverse bias is given. Magnitude of current under large reverse bias is given. There is a equation I equal to Is plus I naught into 1 minus e power v by eta vt. 1 minus e power v by eta vt, where I naught is reverse saturation current. Is the short circuit reverse current caused by light intensity. V is the reverse bias voltage across the diode. Vt is the voltage equivalent of temperature. Eta is parameter, 1 for germanium, 2 for silicon. Eta. So this is the current equation for the photodiode in a reverse bias. So we have to remember this equation. This is the operation. So as a rectifier diode has a very small reverse current when it is reverse bias. Reverse current increases with temperature due to increase in the number of electron hole pair as temperature increases. When there is no incident light, reverse current is almost negligible. It is called dark current. So we have to see the dark current. When there is no light is fall onto the junction, reverse current is almost zero and it is called dark current. When light fall on reverse bias PN photodiode junction, additional electron hole pair generated, which has the light has and is photo energy amount that can be converted into electron hole. The movement of these electron hole pair in properly connected circuit result in current flow. The magnitude of photo current, which is depend on number of charge carrier generated, hence on illumination of the diode element. This current also affected by frequency of light falling on the junction of photodiode. So next we have to discuss the characteristic of photodiode. This is the characteristic curve. We have to see the reverse voltage versus reverse current. Reverse voltage from 0 to minus 5 minus 1 to minus 5. Reverse current is in micro. And the curve shows the light fall when 0 lumen for meter square, 100 lumen for meter square, 1500 meter for lumen square, 2000 2500 lumen square. As light increases, the reverse current graph will be increased slowly. We have to see, observe. So we have to calculate this current the reverse resistance At reverse voltage 3 and current, we have to calculate resistance. The dark current we have to calculate for this particular device is approximately 25 microampere at reverse bias voltage of 3. The resistance of device with incident light is 3 volt by 25 micro, gives the dark resistance 120 kilo ohms. At 20,000 lumen per meter square, the current is approximately 300 micro at 3 volt. The resistance under this condition, these conditions, 3 by 300 micro ampere gives the 10 kilo ohms. These calculations show that photodiode can use it as a variable resistance device controlled by light intensity. So we can vary the resistance based on the light intensity. So unit of light is lux or lumen per meter square. Reverse current increases in direction proportional to level of illumination. Even when no light is applied, there is a minimum reverse leakage current called a dark current. Even when no light is applied, there is a minimum reverse leakage current called a dark current flowing through the device. Germanium has a higher dark current than silicon. At the same time, it has higher level of reverse current. Increasing the reverse voltage does not increase IR significantly. So each characteristic is approximately a horizontal line. So this is a working, construction and operation and a characteristic of photodiode we have to discuss. Next topic is we have to discuss the construction detail of phototransistor, characteristic of phototransistor, operation of phototransistor. So we have to see the it's working symbol. This is a symbol of photo transistor. It is collector, emitter and base. We know that when transistor work in active region, the collector to base region is reverse bias and base to emitter region is forward bias. So we have to use the property of reverse bias. So light must be fall at the collector to base junction so that there is a reverse bias exists. We have to use it work as a like nominal photodiode. So there is a lens construction wise, all we have to say it is packed in plastic capsule and there is a lens across the PN junction at JC. It is a normal transistor which is base terminal is opened. Yes. And emitter collector junction we have to apply reverse bias with the load RL. So all are the similar to the normal transistor, but it is closed with the one plastic capsule with the opening at a junction. So emitter area is seen to be quite small to allow incident illumination to pass to collector base junction. It is generally connected in a C configuration with the base open. So we know the advantage of C configurations, but here base has to be opened. Phototransistor packages are similar to photodiode packages, except that 3 terminals are provided. Phototransistors are usually contained in a diode-type can with a lens at the top. Clear plastic encapsulation is also used. A lens focus the light on base collector junction JC. Although phototransistor has 3 sections, only 2 leads, the emitter and collector lead, are generally used. In this device, the base current is supplied by the current created by light falling on the base collector photodiode junction. We have to observe this point. In this device, base current is supplied by the current created by the light falling on the base collector photodiode junction. So why we are going for this phototransistor is current developed by photodiode is very low. That is a disadvantage of photodiode. This current cannot be used directly in control applications, but must be amplified after amplification. Photocurrent may be high enough to be used in control system, for example to set a relay. Phototransistor is a light detector with combines photodiode and a transistor amplifier. Phototransistor is a light detector which combines photodiode and a transistor amplification. That is the advantage of this phototransistor. So PN construction is NPN phototransistor, that is PN or NPN. We have to use NPN most commonly. So NPN phototransistor, which is generally used in common emitter configuration. The bias voltage is applied between emitter collector junction with the base left open. Bias voltage is applied between emitter collector junction with base open. The construction of phototransistor is just like conventional semiconductor PNP transistor. here in this. A small lens is fixed on the in this window for allowing focus light beam to concentrate on the base collector junction. A small lens is fixed on this window for allowing focus light to beam to concentrate on base collector junction. So photo transistor similar to ordinary except that no base terminal is provided. Instead of base current, the input to the transistor is provided in the form of light. It works on the same principle of photodiode. Now we have to see the operation and characteristic of this photo transistor. This photo transistor. When transistor is kept in darkness, no light is falling on phototransistor. So very small reverse saturation collector current is flow, but the current is negligible. This current is called dark current. This current is called dark current. When light fall on the collector base junction of the phototransistor, there is a transfer of energy from the incident light, which has the incident light has a photon, to the atom in the junction. This will produce thermally generated electron hole pair, which are crosses the junction. This will create more free electron holes or more holes. The photo generated magnetic charge carrier will produce reverse saturation current. Photo generated magnetic charge carrier will produce reverse saturation current as soon as light source is applied to the phototransistor start conducting and amplified the current start flowing through the collector. Amplified current start flowing through the collector. As soon as the light source is applied to the phototransistor, to start conducting and amplifies current start flowing through the collector. The electrical output is taken across the load resistor RL. So how it is amplified we have to discuss. The current in ordinary transistor with the base terminal open circuited, the collector base leakage current ICB0 will act as a base current. Since we know the equation IC equal to, we know the equations, IC equal to beta time IB plus 1 plus beta time 1 plus beta time ICB0. So IB terminal is open, so IB current equal to 0 because it is open. So IC current is IC equal to 1 plus beta time ICB0. This is the collector current of phototransistor. So in phototransistor, ICB0 is increased when collector base junction is illuminated. When ICB0 is increased, collector current also increases. Therefore, for a given amount of illumination on every small area of phototransistor, provide a largest output current. Therefore, the phototransistor is a light detector. Which combines a photodiode and transistor amplifier. So this is the operation we have to discuss. As soon as light source is applied, transistor start conducting, amplified current flowing through the reverse bias junction. On light being focused at the collector base junction, additional photo generated minority charge carrier will be available, which will add to the reverse saturation current. Now we have to discuss the characteristic. So advantage of phototransistor, from the equation we can see that IC equal to 1 plus beta time ICB0. So normal diode has only ICB0, reverse current only, but here 1 plus beta time current, so it is multiplication of the phototransistor produce higher current than the photodiode. That is the major advantage. Phototransistors are relatively inexpensive, simple, small enough to fit several of them on a single integrated chip. So small chip it has. Phototransistors are very fast and capable of providing nearly instantaneous output. But it has a instantaneous output. It produces instantaneous output. Phototransistors are fast and capable of providing instantaneous output. Disadvantage of phototransistor is that are made of silicon are not capable of handling voltage over 1000 volts. Switching speed is low compared to photodiode. That is the main disadvantage. Switching speed is very low. So That is a main disadvantage. The characteristic curve is, you have to see is here. These are the characteristics seen to be similar to BJP characteristic, except that base current level are replaced by illumination level. Base current replaced by illumination current. So typical collector characteristic curve of phototransistor as shown here. This curve depicts the variation of collector current with the collector emitter voltage for various value of illumination, which is expressed in unit of lumen per meter square or lux. A study of this curve reveals the following facts. Study of this curve reveals the following facts. The current in a phototransistor is depend mainly on the intensity of light entering the lens. So current in phototransistor is depend only on the intensity of light entering the lens. Photocurrent is less affected by the voltage applied to the external. Photocurrent is less affected by voltage applied to the external. So this is the characteristic curve we have to study. So advantage is only it amplifies the current compared to photodiode. So IC current is 1 plus beta time ICB naught. So ICB naught depend on temperature. So ICB naught current will increases enormously as when we illuminate more. So phototransistor provide much larger output current than that of available from photodiode. Phototransistor is most sensitive of the two devices, but it has a disadvantage is switching speed is slower compared to photodiode. So as temperature increases from 0 lux to 300 lux, 600 lux, IC current will increases in milliamps. So IC versus VC, instead of base current we have to illuminate the base region. So base current can be replaced by illuminated lens illumination. So unit is lux. So application of photodiode, we see that transistor find extensive application Phototransistor find extensive applications. First, high speed reading of high, high speed reading of computer punched card and tapes. Computer punched card and tapes it is mostly used. Light deflection system, light operated switches, light operated switch, reading a film soundtrack. Olden days most commonly used reading a film soundtrack. Production line counting of object which interrupt light beam. Security system used in optical communication. IR photo detector, counting system, light operated switch, electric controls, light controls in highways, light detection system. So many applications it has. We have to see. So this is the applications. Similarly, photo diode we have to saw. Photodiode also similar applications like a phototransistor, light detector demodulation, used in the receiver of optical communication, counting purpose, soundtrack film, security system, light operated switch, electronic control switch, used in optocouplers, used in encoder, measure speed and directions. Next session we have to discuss the LED, how the LED constructed, how it is work, what is the basic principle, what are the material it requires, what are the applications of LED, and we have to discuss the photovoltaic cell. So photovoltaic cell also called photovoltaic solar cell, also called photovoltaic cell, is a semiconductor device which is used to convert light signal into electrical signal. It produces electrical signal when it is exposed to sunlight. So photovoltaic cell consists of one or two layer of semiconducting material, usually made of silicon, which contain no liquids. The chemicals are moving part. They produce electricity as long as light shine on them. The greater the intensity of light, greater flow of electricity. They require little maintenance. Do not pollute, they operate silently. Next topic we have to discuss the construction working of photocell. photo means light, voltaic means electricity. So simply photovoltaic means electricity from light, electricity from the light.